Hello, everyone. So this is another question from HL Paper 1 in the November 2017 batch. This question, they're asking us, what is the pressure in pascals inside a 1 meter cubed cylinder containing 10 kilograms of H2 gas at 25 degrees Celsius? And they've given us the gas constant, which is 8.31. And they've also given us the ideal gas equation, which is PV is equal to nRT. I'm sure most of you would have heard of this by now. And this is also available in your formula booklets, but as I've mentioned in a previous video, you do not get the entire formula booklet in paper 1. You only get the periodic table. Anyways, so just by looking at this question, the very first thing you should notice is that two options in this are completely wrong. And you can just spot that. And those two options are actually A and C. Now, why these are wrong is because of the temperature that they use in these equations. They have used the temperature as 25 degrees Celsius. Now, this is the temperature they've given it to us in the question. But what you must remember is that in the ideal gas equation, you cannot use temperature in degrees Celsius. It has to be in Kelvin. This is why I've placed this box over here. It tells you the units that each of the variables need to be in. So pressure needs to be in pascals, volume needs to be in meter cubed, and temperature needs to be in Kelvin. And well, the gas constant is 8.31. So that's what the units need to be. So that's why you can immediately eliminate A and C. Those are wrong. Now we're left with B and D. So I'm just going to kind of solve this through and hopefully you understand what I've done. So it's PV is equal to nRT. Now remember, N is moles. These are the moles of the gas. So now we're trying to find out what pressure is. So we just kind of isolate it like we do in maths. It would be P is equal to nRT over volume. And the number of moles can be easily calculated. We have the mass, which is 10 kilograms. But remember, if you want to calculate the moles, we have to have the mass in grams. So that would be 10,000 grams divided by the molar mass of H2, which would be 2. It's actually around 2. It's 2.02, but for the sake of simplicity, we'll take it as 2 because it's nearly there. And this would give us 5,000 moles. That's a lot. Now we just substitute the values in. We can say 5,000 times 8.31 times temperature, but in Kelvin, which is 298. Sorry, I'm just going to move this over here because I think I've got it a bit congested. 5,000 times 8.31 times 298 divided by the volume in meters cubed, which is just 1.0. Now, if you look at this, the B and C, the answer is D, because it's, well, 5,000 is nothing but 5 times 10 to the power of 3. So D is the answer. Now, I'm just, as usual, as I did with my previous video, I'm going to give you a few extra tips and pointers. So if you're interested in hearing that out, do stay. If you want to know how to convert from Kelvin to degrees and vice versa, sorry, forgive my handwriting, I will show you how to do that. It's very simple. If you have, suppose, 25 degrees, just add 273 and you'll get your answer in Kelvin. So that's how you do it. And again, of course, if you have Kelvin, suppose you have 298 Kelvin, just subtract 273 and you'll get your answer in degrees. Now, if you want to convert between meter cubed and decimeter cubed, I'll show you how to do that as well. So I know that conventionally in IB chemistry, most calculations require you to have the volume in decimeter cubed. For example, if you're calculating the number of moles of a solution, so on and so forth, you use decimeter cube, but in this you're required to use meter cube. So how you do that is just dm cubed divided by 1,000, and that is equal to meters cubed. So that would be it for this video. I hope you learned it, and I hope I am better than last time in terms of speaking and stuttering. And yeah, I will see you in the next video with a brand new question. Thank you.